So we talked about the difference of squares before. We used that with last lesson's problems. And so all we did to do the difference of squares was start off with, you took the square root of each item.
What's that little dot?
It was a dot. It's just the number itself, not the sign. On this one. And so we have x plus 8, x minus 8 is a format. So if we do this on the second one, square root of x to the fourth is x squared. Square root of 16 is 4. So what would my next parenthesis set be?
X squared, something 4. Right.
So now, unlike this last problem, we now still have squares in it. The x squared plus 4 does not have a subtraction sign in between it, so I can't do anything over the reals. So let's write it down. But this x squared minus 4, there is a minus sign in between it, so I'm going to see if I can factor it one more time. And so we have x plus 2, x minus 2 that was the factoring of those two. So that's it factored completely. So you try to get it down to where you have no powers on your x when you factor it completely. Only linear parentheses. It's not always going to work, especially if you're doing it over the real number system, because some are going to have imaginary solutions for that point.
Would you not do the other x squared plus 4?
Since we're doing it over the real system, this really factors into, if we're doing it over the complex, x minus 2i, x plus 2i. But since we're not doing it over the complex system, we do not have to do that.
Wait, what? Why would it be I?
Because it's always the square. You always take the square root of the opposite of whatever this number is. So it takes the square root of 4.
Oh, shoot.
And we'd be taking the square root of negative 4. And so there's the I is involved. Okay?
Is our test this week or next week?
Next week. The end of next week.
Do you know what our history star test is?
Next Thursday.
Like next week?
Okay, so let's do the same thing on this one. What's step 1?
Find the square root.
What's the square root of x to the 8th?
We could go x to the 4th.
Mm-hmm. And square root of 1 is 1. So we have x to the 4th plus 1, x to the 4th minus 1. So with the plus sign in between it, I'm done. I can't go any further with that parenthesis. When there's a subtraction sign in between it, I can look and see if I can go further. So can I take the square root of x to the 4th? Becomes? Can I take the square root of 1? We've already said that. It's 1. So that becomes x squared plus 1, x squared minus 1. So I'm going to write down the things that can't be factored any further. can I take the square root of x squared?
Yes.
Can I take the square root of 1?
No, yes.
So x plus 1, x minus 1. And so it's done at that step.
Why can't you do anything with the plus one?
The plus 1s would end up with the i's,
Because it's opposite.
because it's opposite is what you're taking the square root of. And so since what I would have to take the square root of would be a -1, that's going to put an I in the place. And we're not doing it over the imaginary. So that's the reason we're not doing it over the plus signs.
Ooh, dead.
I want you all to try to do D. So check your answers with what I just did. So we have Kingston and Toby. We're going to look at Kingston and Toby's work. Kingston says he used the properties of equality to determine the factor. He came up with the factor of being x equals 2. So we found out the trick is if we have that factor, we set it where we have the opposite sign in the parenthesis. So x minus 2. And he said, well, I don't have anything else, so I'm just going to put it 3 times. Toby, on the other hand, looked at it, he graphed it, and he said, okay, I have the x equals 2, that's one of the zeros, but because it's going through there, I know it can't be the only one, there must be 2 imaginary. So Toby is right. What Kingston did is he just found the only real solution. We need to also look for the other imaginary solutions. And so to do that, we are going to take and divide this out. If you like the long division, you can use the long division. Just make sure you put your placeholders of 0x squared, 0x, and that's what we're going to be dividing.
What was Kingston's error?
Kingston's error was he did not consider the imaginary solutions. And so we have x minus 2 from what the one that worked for both Kingston and for Toby. We need to find the 2 imaginary. So we start off with writing the x cubed and we write out the factor. And then we're going to try to create the center to look like this. And remember, the top and the side multiply to create the center. And so to go up, I'm going to divide. So x cubed divided by x gives me x squared. That goes here. Coming down, I multiply. Then my diagonal needs to add to be 0. So I need to figure out negative 2x squared plus something has to equal 0x squared. What would this something be?
2x, right?
So 2x squared goes here. To go up, I divide. So 2x squared divided by x is equal to 2x. You write that above. We multiply to come down, so negative 2x. And then we take and look at our diagonal. And we're trying to create this positive 0x.
Would that be negative 4x?
Oh, yes, it would be negative 4x. Thank you for catching that. And so negative 4x plus something is equal to 0x. What is that something? What would I need to add to negative 4? What? 4x. How would I find the number above?
By multiplying because x, 4 times x equals 4x, so it'd be like 4.
So it'd be 4. And so coming down, I multiply. This number and this number match, so you're done. So my two parentheses would be x minus 2, x squared plus 2x plus 4.
Where'd you get the x minus?
From the one that we knew worked. We knew one of them worked.
Oh, okay.
And I'm going to show you how he used the property of equality on this next one, so you can see where that number comes from.
Yeah, go back over it. Oh, shit.
So we're going to do the same thing. Oops, I forgot to put this one a little bit high. But we first have to start off with solving that property of equality. And so 0 is equal to x cubed minus 27. What do I need to do to solve this? Add 27. So it's 27 is equal to x cubed. So that means some number times itself 3 times is 27. So in other words, the cube root of, what is the cube root of 27? Not 7.
Oh, wait.
So cube root of it. So what number times itself is, so like 2, the cube root of 8 is 2. 2 times 2 times 2 is 8. What number times itself 3 times gives me 27?
9.
3. So that means that my factor is x minus 3. That's what's going here. And remember, this is the same thing as x cubed plus 0x squared plus 0x minus 27. So what goes in this first spot?
X cubed.
How do I find the number above?
9.
So we get x squared, multiply coming down, negative 3x. So negative 3x plus what is equal to 0x?
Isn't it square?
Oh, it is. Thank you. So 3x squared. So divide going up. Multiply coming down. Negative 9x plus what is equal to 0x? Divide going up, we get 9. Multiply coming down, we get negative 27. Does that check out? Yes. So that means that my factors are x minus 3 times x squared plus 3x plus 9. I want y'all to do 20, or actually let me get you started on this one, and then I'll let you finish up the division. So I subtract it now to get the 27 over here. What is the cube root of both sides? It will be negative 3 this time because negative 3 times itself 3 times will give you a negative 27. So that means that we will make our factor, it is x plus 3 as our factor. And just remember, this is the same thing as x cubed plus 0x squared plus 0x plus 27. I want you to go ahead and divide this. So you should have come up with the product of x plus 3 times x squared minus 3x plus 9. So we're actually going to look at the 3 that we just did and see if we can find out any patterns. There are some patterns here. So we had x minus 3 times x squared plus 3x plus 9. We had x plus 3 times x squared minus 3x plus 9. And that was when we had the original equation of x cubed minus 27, x cubed plus 27. Okay, and then when we had x cubed minus 8, we had x minus 8, excuse me, x minus 2. And second parenthesis was x squared plus 2x plus 4. And so if I was to come up with a rule for these, what would my rule be? How can I come up with that first parenthesis from the original problem? So how did I get x minus 3? Or x minus 2, or x plus 3? How did I come with those numbers? Equaling those to 0. But really what it ended up being is the cube root of this and the cube root of that, right? Cube root of x cubed, x, cube root of 27, 3, or you could have equaled it at 0, and it works the same way. But the shortcut is just taking the cube root of both. How do I know what I'm going to place here? What sign? Because these two have minus, this one have plus. How do I know if I'm going to put a positive or a minus in the first parenthesis? Anybody see a connection of where I can pull that sign from? Look at your original problem. And look at that first parenthesis. How can I pull that sign?
You see first parenthesis, which
Mhm.
one?
So looking at that first parenthesis on each one of those. How can I determine my sign?
Oh, by the sign.
By the sign of the original. Now let's look at the second parenthesis. How do I find this first thing?
Because x squared plus.
It's the square of the first. Number in first parenthesis. You don't have to write all that stuff. I just wanted to make sure you understood where I was pulling that number when I'm saying first. What about the sign in between? How do I determine that sign? Because these two are positive, this one's negative. So how would I know if I'm going to put a positive or a negative? I don't know if I'm going to add or subtract. Opposite. How do I find my next term? How do I find that 2x, the 3x, the 3x? How can we find that number? Where might that number come from?
Square root.
It's not the square root.
Is it the number in the first parenthesis?
It's the product of the first parenthesis. What sign is going to go next? So what sign was my last sign on all of these? Always positive. How do I come up with this last number? How do I come up with the 4 or the 9?
If you multiply it with the other number, it equals the number.
Okay. So what times that other number equals -8? Or square the first. second number in first parenthesis. So 2 squared is 4. 3 squared is 9. And the shortcut I remembered it with is square product square. Get you that second parenthesis. So once you find the first, square product square, and you just have to remember how the signs work. And SOAP was a good way to remember the signs, same, opposite, always positive. I'll come back to this page so you can look at it as you're doing it, but I want y'all to do A and B. So let's kind of talk through it on B. What is the cube root of 8x cubed? What's the cube root of 8? What times itself 3 times gives me 8? 2. So that's 2x. What's the cube root of 1? And remember, we always do the opposite sign of whatever that is if you want to come up with it, or if you want to just take and not worry about the signs unless you're doing it here. That's okay as well. So it's a cube root of 1. So 2x, same sign, 1. So square, give me 4x squared. The product gives me 2x, and I do the opposite sign. And then I square the last. 1 times 1 is 1, and it's always positive. So I want you to try to do C and D. C and D are going to go multiple times. And it may or, oh wait a minute, that's the wrong C and D, isn't it? Okay, I accidentally deleted out the wrong thing. Let me get those pulled back in. So do C and D here. You are going to have to do it multiple times, or have to use both rules. So on C, because you can't take the square root of 2, you're done at this state, even though there's still squares involved. So we can't do anything with that second parenthesis because we know it's imaginary solutions at that point. But we can factor that first parenthesis one more time using the sum of cubes. So that's your final answer. For this last bit, we're going to divide these. And you know how I talked about that we don't always come out divided evenly? So up to this point, we have divided evenly each time. Now we're going to have some that don't. And so when they don't divide evenly, what will it look like? So we're going to start off the same way we've been doing. Nothing's really going to change until we get to the end. And so we have the x minus 4 outside. X cubed goes here. How do I go up? X squared. Then to come down, negative 4x squared. So negative 4x squared plus something gives me 2x squared. And that's this diagonal here, trying to get this number here. So what would that something be?
No,
6x squared. How do I find the number up? We divide to go up. Then we multiply coming down. So negative 24x plus something has got to equal negative 5x. And so to find that something, what number plus 24 is negative 5? 18. No, not 18. 19. Oops, not 19x up there. Sorry, I put it in the wrong spot. And then 19 times what? Negative 4 is negative 76. So negative 76 plus what is equal to 16? Because these numbers do not match. So I have to go one more step. Plus 60. So this is my remainder. And so my solution when I divide that is x squared plus 6x plus 19 with a remainder of 60.